Okay, so here are a few examples on how to find the area of a composite figure. So real quickly, a composite figure just means that it can be broken down into two or more of the basic shapes that you already had to find the area for. So normally you would have rectangles or squares, and we know that the formula for that is simply that the area is the base times the height. You had to find the area of triangles, and the area of triangles is 1/2 the base times the height, where base and height always have to be perpendicular. And then you also did circles, and the area of a circle is pi r squared, where r is the radius. Okay, so since a composite figure is a figure with more than one shape, step one is always just going to be to find the different shapes. Okay, so for example, when I look at this figure, okay, I see that I have two shapes. I have a triangle and I have a rectangle. Okay, and I'm just going to find both of those areas independently. So again, if I'm finding the area of a triangle, it's going to be 1/2 the base times the height, where the base and height are perpendicular. So because this side over here is 8 and it's a rectangle, I know that this side over here is also 8. Okay, so when I'm looking at just my triangle, the base is 8, the height is 6. So the area of the triangle is going to be 1/2 of 8 times 6. 4 times 6 gives me 24. Okay, then I'm going to find the area of the rectangle, which is base times height, so it's 10 times 8, which is 80. But I'm looking for the area of the entire thing, so I have to add those two answers together. So 80 plus 24 gives me an area of 104, and since you're multiplying meters times meters, your units would be meters squared. I believe Khan has already taken care of the units for you, so really you just have to find the numerical answer. Okay, so then what if we have a shape like this where a shape has been cut out? So the key here is that if I extended these sides, I would have a square that is 20 by 20. Remember, these marks mean they're congruent, so because this is 20, this is also 20. Because these are congruent, since this is 10, this is also 10, which must mean that this here is 10. Okay, so I know that I can find the area of the entire square by doing 20 times 20, or 20 squared. It's a square, so squaring, which is 400. But that's the area of this entire thing, right? And I want to cut this piece out. It's not actually there, so I have to also find the area of this quarter circle. And so I know that the area of a circle was pi r squared, where r is the radius. So if this were a full circle, the area would be pi times 10 squared. But it's not a full circle, it's a quarter of the circle. So the area of your quarter circle is going to be 1/4 of pi r squared. Your radius is 10, so 1/4 of 100 pi gives me 25 pi. Okay, because it is cut out, you have to subtract. So your total area is going to be 400 minus, because you're cutting it out, 25 pi. Okay, so if you're adding on to, you take the areas of each part and you add them. If you're cutting out of, you take the areas and you subtract them. Make sure you're always doing the big, the total, minus what's missing. Okay, so then what if you had a problem like this? Okay, well there's actually two ways that you can solve it. You can either divide it up so that you have 3 rectangles that you're adding together. But I think the easier way to do it is to think about moving this line up, okay, and thinking of it, okay, I need to find this entire piece, and then I need to subtract out, cut out this little well. Okay, so what is the big shape? The big shape, I went way too far there. The big shape is a rectangle. How do you find the area of a rectangle? It's just base times height. So that's going to be 15 times 30, which gives me 450 millimeters squared. But then remember, I need to cut out this piece, which is a rectangle that's 8 by 10. So it's the small rectangle, okay? And so 8 times 10 gives me 80. Again, you're cutting this piece out, so what do you need to do? You need to subtract. So the total area is going to be 450 minus 80, which gives me 370 millimeters squared. Okay, last but not least, what if we make it really complicated with something that looks like this? Okay, they haven't given me any sort of dividing lines, but I know that I can add them in. So I might add a line here so that I have a triangle that I can find the area of. Okay, and I like right angles so that my base and my height are set perpendicular. Okay, I could also cut something there so that I have another triangle down here. Okay, but then this leaves me some sort of like awkward space. So it's your choice whether you want to cut up to create 2 rectangles or cut across to create 2 rectangles. And I think I'm going to cut across. Okay, so now I have this small rectangle and I have this big rectangle. So I have to find the area of all those different pieces. So if you want, pause the video and see if you can figure out what the area is before I go through the explanation. Okay, so I'm just getting my paper set up so that I can keep track of everything that I've done, make sure I'm not duplicating anything. Okay, so I have these 4 different parts that I'm going to have to find the area of. Okay, I know that the green is a triangle, the orange is a triangle, the blue and the pink are both rectangles. Okay, I know that to find the area of a triangle, I need to do 1/2 base times height. So great, I have that this height is 6, but I don't know what this base is here. Okay, well the key is that the entire thing down here was said to be 15. So if I've already used 6 up here, that must leave me 9 remaining. So I know that the area is going to be 1/2 base, 9, times height, 6. So 3 times 9 gives me 27. Okay, for the rectangle, the blue rectangle, this is 6, and then this is the entire width of the figure, so it's 15. So the area is just going to be 6 times 15, which gives me 90. Okay, so then here, this little triangle, okay, the key is it told me that this is 6, but what's this? Well, if this entire side over here is 9, and I've already used 6, this must be 3. So the area of that is going to be 1/2 of the base, 6, times the height, 3, which gives me an area of 9. Okay, last but not least, I need this last little rectangle. This entire thing is 15. This piece here is 6. So again, that leaves me with 9 here. It's a rectangle, so the area is just base times height. So 9 times 3, which gives me 27. Okay, these are all pieces that I'm adding together. They're all part of the figure. None of them's a cutout. So in order to get the total area, I'm just going to add those things together. So 27 plus 90 plus 9 plus another 27. You can use your calculator. It's not banned. So add them up. And the total area is going to be 153. I hope this helps with that con assignment, and if you have any specific questions on any of these examples that you need me to go into more detail with, please just let me know.